Hello, one and all. Welcome all of you for the workshop Kickstart to IoT. Here, today I am explaining IoT Simulators. I am Smita Bansod, Assistant Professor, IT Department, SAKEC. So, Arduino Simulators, we are basically discuss here. What is simulator? Simulator is nothing but a virtual representation of real world of any circuit. Basically, here we are discussing about Arduino circuitry. So, what are the advantages? We can learn and teach to the how to code the Arduino and build the circuits anywhere by using computer and internet access. No need to use the actual hardware because it is much easier to find out the hardware or wiring the error in the simulator than struggling with a meshy wire in the actual circuit. So if you are connecting the wire, so maybe there is a fuse of like that issue, otherwise sparking and all that things are actually happen in actual hardware. So to avoid that, first we will develop our virtual circuitry, means the on a simulator we are design our circuitry, write a code, understand that, and then we will actually use the hardware so that we can save the life of other hardware, as well as you can share your design with a peer student and discuss and explain the important concept involved. But there are certain disadvantages. That is, the simulators is having some limited components. Whatever the components we require for our application, maybe all the components are not available in the simulator. If you want all the simulators, so you have to pay, because good simulator are not free. As well as when we are using the simulator, we require internet or Wi-Fi connectivity. So these are the simulator list. So online, basically these online simulators are free of cost and available openly. That is Tinkercad, Walkie, and Circuito.io. And this is the list of offline Circuito simulators. For that you have to pay. And these are the good simulator, means maximum devices, hardwares are available on that. We are here discussing about the Tinkercad. This is also very good simulator, that is Walkie in 2020. This is in a boom, but this is a complex one. So we will start with a simulator, that is Tinkercad. So for that you just Google Tinkercad. So you will get this tinkercad.com. Log in into that. So you have to just select the student ID and then you can log in into that. I have already logged into that. So you can use the sign in option and then Google form. Otherwise, as a user, you have to log in and then you can easily access this Tinkercad. You have to just go to the circuitry. This already have designed one. If I want to design new one, then go to the create new circuitry. Here, the different 4 types of wires available, different colors of the wires we can select. These are the different components, the code and the simulation of that particular things. So first I want Arduino. So click on that. I'll just take this, drag and drop the Arduino board. If I want to minimize the size, I just press Ctrl- so that I can minimize. So on the screen, I can fit the hardwares. Now I want breadboard. So I just type breadboard. So there are different kinds, means mini breadboard or small breadboards are available. So for connectivity, it is better to take this breadboard. Then I want to just blink the light. So LED. I'm selecting here LED. I place here in a breadboard. Just drag and drop here. In a breadboard, these are horizontally connected with each other and these are vertically connected with each other. Here also same thing. Okay. Now for controlling that, I want a resistor. So this cathode, so that I can connect that with the ground, and this is anode. I can connect with a voltage to provide the power supply to that LED. So for that, I want a wire. So I am selecting here a normal wire. Color I put as a green only. So from pin number 13, I connect the, just click here and stop there. Okay. So I am connected here the anode with a resistor. So these are vertically connected. So I can connect this point with this resistor and resistor point with this 13 number pin. Now I have to also join the ground pin. For that I consider red color. Sorry, this is green. Now I have to consider some other wire. So for that I have to consider the red color so that I can differentiate between these wires. And now I just connect that with anode. Yes. So my circuit design for LED blinking is ready. Now I have to go for the code. So here, if you don't know about the coding, so you can use this block. So output, input, notation, control, maths are available here. So if you just go for the input, so you for reading the pin, analog, digital, you can use these blocks. So here, just I have to blink that. So power voltage is high, wait for 1 second. Power voltage is low, and then wait for again 1 second. And likewise, in a loop, I am calling that. So this wait, that is in a loop. Okay, so in a loop, I am calling this function. But you are aspiring for engineering. That's why I suggest you to use the text format, where it is a C++ code. We have to write a function that is a setup, means 13 pin is for output purpose, and we are calling the loop function to continuously call this particular block where I'm writing digital write. Okay, so 13 pin high voltage delay of 1 second, then digital write on 13 pin low and delay of 1000 milliseconds. Okay, so in this way, first I say that to 13 pin voltage is high, stop there for 1 millisecond. Then I say, I give the order to that pin number 13. Now voltage is low, means off. So 1000 millisecond, it is in the off position. Again, I'm calling that. So in this way, code is done. Then I start the simulation, means run the program, and simulation is done. So for 1000 millisecond, 1 second, you can see here the light is blink on and after off, on, off. So likewise, we can write a program in our own. We can just give the name to that program, experiment number 1, because whatever the names they have given, this is some different name. Okay, so in this way we can write a program and we can simulate that. So this is other program which I have already designed the circuitry for this. I just tinker this because it is already existing program. So I just drag this Arduino board, breadboard. This is piezometer and LED. So this connection is similar whatever we have discussed right now, and this connection positive I have attached to the ground, here ground, and a negative I have given to the 12 number pin. Related to that, I have completed the code, that is 12 number 13 and 12 I am using, and just I have to on and off the power to that both LED and piezometer. Now start simulation. You can hear the audio of piezo and the LED blinking. Now, if you have to learn more about this, so you have to just go through this learn, find out the circuits, this circuitry is already developed by your friends. Okay, so you can select any one from that. You can search LED. So you can see here circuitry. So you will get here different LEDs programs. Now specifically, if you want to provide the LED blinking in some pattern, okay, so you can call this program. Okay, you just copy and tinker this program. So this is with you, the copy of LED pattern. You can give the name, whatever you want. The code is already exist here. So what is define T and all that things, effect of that. And likewise the code, so you can understand this code also. And start simulation. So in a pattern, you can blink the lights. Okay, so the code and everything is available here. You can work on that. So you can learn more programming and write your own program like this. This is LED bar graph. So this is already designed. So I tinker this. It takes some time tinkering with this bar graph. So in a pattern, in this piezo, I just start simulation. So with this potentiometer, we can adjust the potentiometer and on and off the light. Just check the blinking off. Now up to this green, now your yellow is blink, and now you can see red. Likewise, you can potentiometer will adjust the light. This connectivity, register and all that things is done. So this all about the Tinkercad. So you explore more, go to the learn section and explore more. Thank you.